All right, so this is homework 4, problem number 4, and we're going to let A be an element of G with the order of A equaling 5, and we need to prove that the centralizer of A is equal to the centralizer of A cubed. Okay, so the centralizer of A is G is an element of G if A times G is equal to G times A. All right, so basically for all X and G, we want to show that AX equals XA if and only if A cubed times X equals X times A cubed. All right, and we're going to use that the order of A equaling 5 implies that A to the 5th is the identity. All right, so the first thing we want to do is show, we need to prove this biconditionally. So we're going to do the out first. So we're going to assume that A times X equals X times A. So we're going to assume the left-hand side, and we're going to try to kind of derive the right-hand side. So first of all, we know that A cubed is the same as A times A times A. So we can rewrite it as A times A times A times X, and we're going to group the first A times X together. Right? And since up above we assume that A times X equals X times A, we can change the order of A times X to be X times A. And so we're basically just going to continue to do that all the way down. And then once we do it this way, we can see that we have A times A times A, and we can write it as X times A cubed. So therefore, we started out with A cubed times X, and we ended up with X times A cubed. So we showed that those two are equal to each other. In the second part, we're going to show the opposite direction. So we're going to assume that A cubed times X equals X times A cubed. This one's just a little bit trickier. So we know that A times X is the same as A times X. And the order of A equaling 5 means that A times A times A times A times A is the identity, right?
Mr. Carter, if you're in the building, please dial 303. Mr. Carter, if you're in the building, please dial 303.
All right, sorry about that interruption. So we have A to the 5th times AX equals A to the 5th times AX. So all we did was just add the identity into that part. On the left-hand side, we're just going to let that cancel out. But on the right-hand side, we're going to turn that into 6 A's. So we have A to the 5th and then that other A as well. Right? And then right below that, we're just going to work with the right-hand side of the equation. We're going to group these 3 A's together and make it A to the 3rd. We're going to group these 3 A's together and make it A to the 3rd. All right? And the assumption we used above was that A to the 3rd X is the same as X times A to the 3rd, so we can move that over. And then we're going to group it such that A cubed X is together, so we can then switch it again. All right, and then we have X times A cubed, which is X times A to the 5th times A. We know that A to the 5th is the identity, and therefore we can get rid of it, and A times X equals X times A. Therefore, the centralizer of A is equal to the centralizer of A to the 3rd.